It's really nice to see most of you back, actually. And in two talks like this, you do wonder if there's going to be anyone left in the second talk or not, so thank you for coming back. In August 2012, NASA landed a rover on the surface of Mars. This is the first 12 months in time-lapse photography of the rover's journey on the surface of Mars, and the rover was called Curiosity. It was called Curiosity because of this young lady, at the time 12-year-old, Clara May, a high school student from Kansas. She won a NASA competition to name the rover by writing an essay. She wrote, "Curiosity is the passion that drives us through our everyday lives. We have become explorers and scientists with our need to ask questions and to wonder." This is the type of subject that as we explore other planets, we might just bear those words in mind. And actually there may be at the moment few answers, but in the curiosity and wonder, in the asking of questions, we get a little bit of that wow factor again. But we also find that there is, in asking the questions, a theological journey which impacts on a whole number of different areas traditionally explored by theology. Martin Rees, the Astronomer Royal, who I mentioned earlier, Lord Rees, says that the search for extraterrestrial intelligence is today our greatest quest. It's built on some of the science that we've been developing with extrasolar planets, and it poses some of the biggest questions on what it means to be human. And so, well, would you like a little video clip this afternoon, just to lighten the tension just a little bit? I talked about the argument for design and popular culture. Of course, popular culture is full of stories about other life elsewhere in the universe. So let me just give you a little bit of entertainment, just for a couple of minutes. Oh, there's no sound. That's all right. Perhaps the good Lord doesn't want us to have some entertainment. We'll move on. That's all right. What I'm going to do is talk a little bit about the history of speculation on many worlds, and particularly the role of Christianity in there. Again, with that coda, I speak from a Christian background. That's not to close down the conversation or the contribution of other faith communities, and simply to recognise the little that I know. Then talk about some of the key scientific arguments as we have them today, and then thirdly, to say, well, okay, what challenges or contributions might this quest make to Christian faith? Is that all right with everyone? I mean, I hope it is, because that's what I've prepared. So it's not, I'm in some problems. I do so against the background of those voices who say this is a very controversial thing to do. Giordano Bruno famously was burnt to death at the stake in 1600, amongst many things, apparently because of his speculation about other worlds. In fact, if you read the story with a little more attention, Bruno was put to death at the stake for particularly some rather odd views about Jesus and magic. But nevertheless, that story is often trotted out. Thomas Paine, in The Age of Reason, commenting on Christianity and the existence of other worlds and those who speculate about such things, claimed that he who thinks he believes in both has thought but little of either. So I come before you ready to be burnt at the stake, and having not thought either about Christianity or SETI very much at all, but just a little bit. One of the interesting things about Christian theology, if we can start there, is how widespread speculation about other worlds has been within Christian theology. Now, that doesn't quite fit, again, with this dominant view that somehow science and religion have been in conflict. Of course, the Greeks in Plato and Democritus had talked about other worlds, but you find in Origen a variety of creatures in the universe. In Athanasius, Basil, and Ambrose in the 4th century, a little more caution, but nevertheless the sense that God could be created wherever God wants to be. It wasn't until Thomas Aquinas came on the scene and effectively baptized Aristotelian theology that Christian theology became a little more worried about life elsewhere in the universe. Why? Because Aristotle had the earth at the center of everything. And might life elsewhere in the universe devalue the special place, the central place of human beings? In fact, Aquinas himself is a little more complicated again than the easy history gives it. Aquinas talked about God as the divine artist, with a sense of extravagance and creativity. Nevertheless, in 1277, the Archbishop of Paris, Etienne Templar, was asked to look into ideas drawn from Christian belief from Aristotle that may be dangerous to faith. He issued a condemnation of 219 propositions that he considered too restrictive of divine omnipotence. Now, this is the key point. What Templar and others were saying was that by saying that we are unique in the universe, we are the only intelligent life in the universe, does this restrict the omnipotence of God to do whatever he wants? And that tension between the free creativity of God and the special nature of human beings, and how you maintain both, was at the heart of a backwards and forwards conversation in Christian theology over whether there were other worlds. In the 15th century, Cardinal Nicholas of Cusa not only recognized that the Earth can have no center, but also suggested the possibility of other Earth-like planets, including more illustrious extraterrestrials close to the Sun and lunatics on the Moon. Now, Nicholas made a key theological move. I quote, "It is not physical centrality that enhances the planet Earth, but human relationship to the Creator of this vast universe. It is not physical centrality that enhances planet Earth, but human relationship to the Creator of the vast universe." Colin Russell, distinguished supporter of Christians in science and Faraday, and many of us owe a great debt of gratitude to, pointed out that the ability to speculate about other worlds for Christians was in part due to this move which said, I don't need to be at the center of the universe to be special. It is because I am in relationship with God as a free act of God's grace that means that I'm special. And that freed Christians to speculate about other worlds. And then, if we move on in the history just a little bit, Christian Huygens and Richard Bentley, who developed some of the first telescopes to really show the vastness of the universe. They didn't get this picture. This is the Hubble Ultra Deep Field, but in their day it would have been just as stunning. Then began to use some interesting theological arguments to support the existence of extraterrestrial beings. They used an argument which went a bit like this. Psalm 19 says, the heavens declare the glory of God. Now, they said, through our telescopes we're beginning to see that the universe is so vast that there will be some stars and some galaxies that will never be seen by human beings. How then can those stars and galaxies declare the glory of God? They concluded, there must be other life forms out there that can see those stars and galaxies and so glimpse the glory of God. I don't recommend that theological argument to you, but nevertheless it's interesting that they actually are employing Christian theology to argue for the existence of life. And so, well, let's sum this up, this little wander into history. This is Huygens' telescope, by the way, which is a bit like what we used to do as kids with two cans and a piece of string between them. Huygens actually put his telescope together with a rope, and on what we've got is a tension going on. There are those following Aristotle who are saying human beings are at the center of everything. Therefore, in order to maintain human status, human uniqueness has to be clear. There can be no other intelligent life forms. This was then supplemented by two things which we may come back to, which is how does the Christian view of sin and salvation relate to other possible intelligent life forms elsewhere in the universe? There's the same problem with those who lived in different parts of the world, by the way. Australians, Antipodeans. Does sin get somehow shared, original sin? And what about salvation? We'll come back to that as it goes on. But there were a number of arguments being used that we were alone. However, against that, and indeed one could say eventually triumphant, was God is free to create. If I believe that God is the free creator of the universe, God can do whatever he wants. And therefore, he could create other beings. God is an extravagant artist. So we should expect extravagance in the universe. That human uniqueness can be maintained not by place, but by relationship. And that the laws of physics are universal because there is one God, and therefore that which we see happening on the earth, development of life, could happen elsewhere in the universe. Now, of course, all of this is against a changing emergence of the scientific method. And as you'll know, one of the things about the Galileo affair was not a direct clash between science and the Bible. It was a clash about how you did science. Did you do science by, as the Greeks' dominant view was, by working out through logic on the back of an envelope what the universe was like? But, said Christians and other faith communities, if God is free to create, the only way we can work out the universe is by looking at the universe, by examining through observation the universe. And so I love this little play on words in 1614. Tommaso Cassini, one of the few priests that we know, attacked Galileo, used the words of Acts 1 verse 11 to attack Galileo with a little wordplay. Ye man of Galilee, why stand ye gazing up into heaven? We're saying, Galileo, why are you doing science by pointing a telescope at the heavens? How vulgar, how awful. You should be doing it with a little bit of logic about what the most elegant spherical shape in the universe is. That's how we do science. Now, because in this area of believing that there are other worlds, God is free to create. So Huygens, Bentley, and others began to say that the only way that we can find out whether there are aliens elsewhere in the universe is to look for them. The birth in some way of SETI, the search for extraterrestrial intelligence. I'm not claiming that Christian theology is the only reason that SETI developed, and simply saying that it made a contribution to it. Okay, so if that's a theological background, let's jump right into the science of today. Because one of the fascinating things is the whole momentum that's been given to SETI by the discovery of extrasolar planets, planets beyond our solar system. If I was giving this talk at the Faraday Institute in 1998, does it exist? 2003. Okay, so well before the Faraday Institute began, I would have stood here and said, the only planets that we know are those planets around our own sun. And in fact, I would have said we're not entirely clear how planets are formed. It might form as the sun itself develops in the solar nebula, or it might be that two stars pass each other and planets are ripped out of one star by another star. And then in 1999, 1995, the first extrasolar planet was discovered by a team of Swiss astronomers around star 51 Pegasi. In 1995, we thought, well, we might find a few. Well, as time went on, the one or two became 10, and they became 100. And this is how it is from yesterday. I have an app on my phone called Exoplanet, which tells me about the discovery of every new planet, which if I had it binging, it would make a sound at least every day, if not more. So this is the number of planets discovered and their year of discovery. We now know of something like 2,000 extrasolar planets in over 1,000 planetary systems, and quite unexpectedly, nearly 500 of them are in multiple planet systems. So we're seeing a planet around a star with neighbours there. Now here's 1995 and that discovery. Notice there are one or two before 1995. This is because they were reported but not believed at that stage. And what I've plotted here is the mass of these extrasolar planets against their year of discovery. In the early days, what you found, this yellow line, is the mass of Jupiter. You only found these large extrasolar planets. As our techniques have developed, so you begin to find planets the size of the Earth. And the rate of discovery, as you can see here, is extraordinary as time goes on. Now, observing a planet around a star a long way away from us is a very difficult thing to do. The reason being that if a planet and you are close to a star, then you can see it fairly easily. But as you move away from that system, so the planet itself is obscured by the light from its star. It becomes almost impossible to see directly. So how have we discovered these 2,000 planets? This is just brilliant physics, I have to say to you. So indulge me for just a little bit, those of you who are biologists or theologians. Let's just rejoice in this physics. So there are now three methods that have been used. The first is the way that stars wobble if they have planets going around them. So gravity tugs from the star to the planet, but also the other way around. The planet tugs at the star. And as the star, let me just start this again so you can see it. So as the star is orbited by the planet, the star itself moves backwards and forwards. And if you observe the spectral lines from that star, they're redshifted and blue-shifted. You can see the star wobbling. And that tells you the radius of the orbit of the planet and its minimum mass. And that was the first method that was used to discover extrasolar planets. The second is even more clever. And that is that if you imagine a planet moving in front of its star, and you're looking at it, the light curve of its brightness dips. Just a little bit, not very much. order to observe this, you've got to be looking at the star and the planet in the right plane to do it. And you've got to be looking at the right time as well when this happens. But the universe has lots of stars for us to look at. And so, can you look at lots of stars in order to see this happening? The answer is yes. This is the Kepler spacecraft, and it observed a patch of the Milky Way just here, and did so for a few years before it lost one of its orientation wheels and went into a different phase of its mission. Kepler gazed for a very long time at just this small patch of sky and saw lots and lots of stars and measured the light curves and looked for those little dips, very small dips of light. And this is what it discovered. Over 3,700 planetary candidates. Some of them are simulated here. So over 3,000 planetary candidates, they have to be then looked at in a little more detail. 400 multiples in 170 planetary systems of all different sizes, from very large Jupiters down to very small Earths around different types of stars.
What proportion of stars have?
Well, we're beginning to think now overall of around about 70%. Of course, with Kepler, you don't see them because they're not in the right plane. And the reason I go on to that statistic, I'll come on to in a moment. Because the third method is even more clever. Is that a phrase? Even more? Anyway, it's late. This is, who would have thought this? And this uses general relativity and gravitational lensing. So, here's a background star which you're observing. As a star passes in front of it, general relativity, no star at this point, I'll come on to a planet at the moment, just a star. The star comes in front of it. Gravitational lensing means that the light is focused, it's bent from the background star, and the light curve increases. If you have a planet here around that star and that comes in front of it, there's a little kink in that increase in the light curve. So here we are, we're looking at a background star, and suddenly you get this little kink due to the planet. Now this, of course, absolutely, they need to be in very special alignment for this to happen. And the fact that we can even see this tends to suggest about 70% of the order of that. It's been an extraordinary scientific story to find how you find extrasolar planets. And immediately from this, you might say, well, doesn't that mean, therefore, that if there are planets everywhere, and we remember from your previous talk, you said there are 100 billion stars, each of 100 billion galaxies, so if I multiply 100 billion by 100 billion, multiplied by 70, then surely, 70%, then surely there must be so many planets out there, some of them must be Earth-like planets. Well, yes, but just hold on a moment or two, there are other factors going on. The first thing we want to ask is whether any of these planets are the right size or the right kind of temperature. And that is, are they a sufficient distance from their star that, first of all, there is going to be liquid water. Obviously, if they're too close to the star, they'll be too hot. If they're too far away, it'll be ice. And we call this range the habitable zone. It depends on the size of the star and the distance of the planet from it. And then we want to know whether these planets are rocky planets, or whether they're just gas giants like Jupiter. Because we think, in order to develop life, you need a rocky planet with water on it. Well, this is one system, Gliese 667c, and here we've got a number of planetary candidates within the habitable zone. possibility. So our 70% now has to be qualified by the number of planets within a habitable zone and our rocky planets and smallish planets. This is another system, Kepler-69. Here we have the solar system with its habitable zone with the Earth. Kepler-69 has a big Jupiter-type planet, very close to its host star, too hot for any kind of life. But here we have 69c just at the edge of a habitable zone. And we now see little planets, small planets. This is Kepler's Hall of Fame as of January 2015. These are the small Earth-like planets that it's discovered. You can see a comparable size to the Earth. And so we've got a sense of, are they the right distance? What are their host stars like? Are they going to be the right temperature? Are their stars about the size of the Sun? Because if the star is too big, it runs through its fuel really, really quickly. It doesn't give a chance for life to develop. If the star is too small, it might actually not be bright enough or hot enough, although there are some models which say that some planets could develop around brown dwarfs. In order to try and work all of this out, Frank Drake, a few decades ago, was holding a meeting on SETI. And he thought to himself, I need an agenda for this meeting. Being a good physicist, he therefore produced an equation for the agenda. A number of factors, which all are multiplied together to give you the number of civilizations within a galaxy that you might expect. The trouble with this is that some of these are so uncertain that you really have difficulty computing the result. But the Drake equation, without going into detail about it, is a reminder of some of the factors which, even though we know that there are lots and lots of stars with lots and lots of planets, and that some of those planets are rocky and some of those planets are in the habitable zone, that's not the end of the story. That's not the way to say, well, there must be intelligent life out there. In 1953, in a classic experiment, Miller and Urey put a number of gases into a test tube which they thought were characteristic of the early Earth. They put an electrical and magnetic discharge through, and out of these gases they got a red-brown sludge, amino acids. And at this point, they thought, and others thought, well, if we can make amino acids in a test tube in the University of Chicago, surely it must be easy to create across the universe. It must be very easy to do. Now put that together with extrasolar planets, and you get a kind of dominant argument, which goes, we've got some planets, we've got some Earth-like planets, it must be easy to create amino acids, therefore there must be intelligent life elsewhere in the universe. Not quite. Two main arguments against it. The first is, as often put it, it's a long way from an amoeba to an accountant. Or maybe not, as the case may be. I mean, you might be able to create a primeval soup through the ashes of dead stars, but even the creation of amino acids through the Miller-Urey effect, but it's doubted today a great deal. But then how do you form proteins, RNA and DNA? And a great deal of interest today is in deep sea hot vents with the clays acting as catalysts to do that. It's not easy to do. And then there's this process of evolution where you need a stable environment over a very long period of time. And then, what do we actually mean by intelligence and consciousness? Stuart Sutherland, a number of years ago, in a dictionary on philosophy under the entry of consciousness, said, nothing that has ever been written about consciousness is worth reading. We don't understand what it is. Now, don't get me wrong, I'm not wanting to hide behind Dr. Gans in any way on this. I'm just wanting to say that even if you form the building blocks of life and understand how that happens, it's still a long story to get to intelligent life. And remember, SETI is a search for extraterrestrial intelligence, rather than just sense life. The second reason why a number of us are skeptical about intelligent life within our galaxy comes from a luncheon in which Enrico Fermi and a number of his mates were walking to in 1950. Fermi had gone out for lunch with a number of other physicists, and as they walked, they were having a little bit of conversation about two news stories that were popular in that day. The first was reports of flying saucers. The second was the strange disappearance of trash cans in New York City. And a famous cartoon in the New Yorker, they'd been put together in one story. And so they were having some conversation and some fun about this, and particularly about how flying saucers might travel. Fermi went into one of his famous silences. Fermi would often just start thinking about something and not take part in the conversation. They got to lunch, Fermi was still thinking about it. The others were talking away. Eventually, Fermi speculated aloud with the simple sentence, "Where is everybody?" It became known as the Fermi paradox. And that is, if they existed, why haven't we seen them? Why haven't they been out? That's right. And Fermi had done something very simple in his head. What he'd done is he'd calculated how long it would take for any civilization to colonize the galaxy. Fairly simple bit of mathematics to do, but you can do it a little more nuanced these days, and you can see this happening in colonization of Pacific Islands and a number of other things to check it. And so you set up a model where, from a home star, you sent out a number of spaceships. These might be humanoid, or they might be robotic. When they reach a new world, they simply create another spaceship and send this out. And so you begin to colonize the galaxy. You build in the fact that some of these will crash, some of them will go to the same world, and you start to model this process and say, how long would it take? With reasonable assumptions about rocket technology and reasonable assumptions about raw minerals and all the rest of it that you'll get on home worlds until you colonize the whole of the galaxy. And what you get is a timescale of 300 million years to colonize the whole galaxy. And you might say that's a very long time. Well, actually it's not, compared to the age of the galaxy of 10 billion years. So Fermi's argument was that if life was developing easily, this life would colonize the galaxy in a very short time compared to the age of the galaxy. If they existed, they would be here, was the Fermi paradox. Leo Szilard, a Hungarian physicist, friend of Fermi, replied to the Fermi paradox, if they existed, where are they? By saying, they're here and they're called Hungarians. That was his response. And of course that takes us down a line of whether we are a visited planet. And we've got time to get into that in great detail now, I'm afraid. But I mean, the kind of bullet points are about hoaxes and conspiracies, and whether some of these claims of being abducted by aliens are actually a result of sleep paralysis, electromagnetic pulses. Is there enough evidence for this, that, and the other? And I don't want to neglect that area or to look down on it, because actually it is an area which has fascinated a whole number of people, and I think we need to take seriously. You won't be surprised if I simply say that I don't think that there's enough evidence for the claim that we're a visible planet in terms of aliens. Which leads me to my own position for what it's worth. And that is, I think, with the current evidence we have, that we are alone as intelligent life within this galaxy. And for me, that stems from the Fermi paradox very strongly. Now, as intelligent life within this galaxy, I think, I hope, that there is a lot of life out there. But it may be very basic life. And Star Trek isn't terribly interesting if it's to boldly go to seek out even more bacteria here, there, and everywhere. But I think we may be alone as intelligent life in this galaxy. However, you might say, well, what about other galaxies? Well, the Fermi paradox doesn't work as strongly, and that could be the case, but there we have a fundamental problem. It's the problem of communication. You see, imagine a civilization, an intelligent civilization in Andromeda, one of our nearest neighbour galaxies. If they send a message saying, hello, is there anyone there? It would take a couple of million light years, a couple of million years to reach us. If we then send a message back saying, yes, we're here, who are you? That message would take a couple of million years to go back. That's not a very interesting conversation at the end of the day. Now, I make fun of it because there's a fundamental problem, and that is that there may be intelligent life elsewhere in the universe, but it may be so far away from us that we would never know that it's there. We'd never be able to detect it. And that is a fundamental problem. However, let me go on now and just say in the final bits, in the final 10 minutes or so, or a quarter of an hour, what does this mean, therefore, for Christian belief in particular? Well, there are a number of voices in this. The first, interesting enough, from Paul Davies, is that the discovery of other life in the universe, never mind intelligent life, might be evidence for cosmic design. We picked up on this in the talk a little earlier. And Davis's point is that if there is other life out there, it must be written into the laws of physics that life is part of the universe, it's part of this Goldilocks enigma. And so he writes, if it turns out that life does emerge as an automatic and natural part of an ingeniously bio-friendly universe, then atheism would seem less compelling and something like design more plausible. He still likes the design word in this way. Now, I think this might be part of one of those questions that we talked about earlier in terms of design that raises the question if we do discover life elsewhere. However, there are other voices which are far more negative. Jill Cornell Tarter, matriarch of SETI in many ways. If you've seen the movie Contact, where Jodie Foster plays this scientist, Jodie Foster's character is based on Tarter. She thinks that there are real extraterrestrial problems for religion. She writes that if extraterrestrial intelligence visited us, not only would they be scientifically and technologically advanced of us, but they would bring with them super advanced alien religions, which would immediately wipe out earthbound religions. Now the problem with this is a fundamental misunderstanding, it seems to me, of the nature of religion. For Jill, religion is really about philosophical development, intellectual development. The main faith communities of the world will say, no, there is this revealed dimension to faith, and she doesn't get that. But many will go with her on this kind of view. The third, and forgive me for mentioning it, but I need to, because it plays out in the popular arena a great deal, and that is that, in fact, God is an alien. favourite books, was written in 1974 by a NASA engineer called J.F. Blumrich. It's called The Spaceships of Ezekiel. And in it he argues that Ezekiel 1 is actually a record of a flying saucer with an alien visitor, the Son of Man, dressed in shining garments, carrying a mobile phone with him, and other things. And Eric von Daniken built on this, talking about religion merging into the visit of aliens. And others have gone into things like the virgin birth was simply an insemination of Mary by an alien, or that ascension was simply beaming up Scotty. The problem with these different views is simply that they don't take the biblical text seriously enough. They extract from the narratives that which they want to prove. By the way, a lot of Christian preachers do that as well at times. But in terms of particularly the incarnation, Jesus, the questions of why such teaching, why such a death and the resurrection never encountered. Now that, you might say, is way off popular rubbish. But a few years ago, in the Quarterly Journal of the Royal Astronomical Society, Professor Edward Harrison produced a similar argument for aliens, which went a little like this, and it picked up on our fine-tuning theme of the previous lecture. Harrison said, if you look at fine-tuning, you can either say many universes, he doesn't like that, or you can say God did it, he doesn't like that. And so his explanation for fine-tuning of the universe is that our universe was created by aliens in another universe, as an engineering project. You then ask him, well, what evidence does he have for that? He has none at all, and totally ignores any claim that God may have revealed himself. So it is around that God is an alien. However, more importantly, it seems to me, are perceived problems for the Christian faith. And these have been highlighted in some of Paul Davis's writings. So Paul will say, maybe life will be question of design, support for design, but alien life would be a real problem for you Christians on two issues. The first is that of creation. So Paul says, you Christians will not be able to understand or hold to your view of creation anymore. However, it seems to me that he falls into the Aristotelian trap here, to think that Christian faith is about the Aristotelian model, that we're at the centre of everything, ignoring the fact that within Christian theology there's already been a movement away from that, to say that human beings are unique, not because we are alone in the universe, but because we have a special relationship of love with the Creator God. And therefore it seems to me entirely possible that there may be other life forms, intelligent life forms out there, which are in relationship with the Creator God, which doesn't devalue in any way the love relationship between humanity and Creator God, exemplified most importantly in Jesus. But the second problem that Paul highlights is one that causes us to pause as Christians and to think a little more deeply. And we're back to sin and salvation here. And it's the question, how does the Jesus event, particularly the Calvary event, relate to other intelligent life forms elsewhere in the universe? Arthur Peacock wrote, does not the mere possibility of extraterrestrial life render nonsensical all the superlative claims made by the Christian Church about the significance of Jesus? Now, Christians have engaged with this. Not many, but some have. E.A. Milne, a distinguished cosmologist, Roman Catholic, wrote, God's most notable intervention in the actual historical process, according to the Christian outlook, was the incarnation. Was this a unique event, or has it been reenacted on each of countless number of planets? The Christian would recoil in horror from such a conclusion. We cannot imagine the Son of God suffering vicariously on each of a myriad of planets. Now, the consequence of Milne's view leads him to the belief that Christians should become cosmic missionaries. Now, the problem with that is it's a very long missionary journey, to say the least. Milne's view was criticised by Maskell in his Bounton Lectures in 1956. And Maskell wrote, if there are, in some other parts of the universe, rational corporeal beings who have sinned and are in need of redemption, those beings and for their salvation, the Son of God has united or one day will unite his divine person to their nature as he has united it to ours. God would become, in part, a little green flesh. And those of you who are part of the Christian tradition might remember an old hymn by Sidney Carter, He of the Lord of the Dance, which he writes, who can tell what other cradle high above the Milky Way still may rock the King of Heaven on another Christmas Day. Now, this is not without its complexity and its problems, particularly at 6 o'clock on a Tuesday evening when really we should be having dinner. The problems and the complexities are this. First of all, are there rational corporeal intelligent beings? Second, that within the Christian tradition, the incarnation of Jesus functions in two ways. The first is to show us what God is like, revelation, and to deal with the consequences of sin, salvation. If you remember again C.S. Lewis speculated in his science fiction whether there might be other worlds where people had not fallen into sin. So if you have other beings who are intelligent, if you have other beings who have sinned, you start to stack up the unknowns. And I think at the end of the day, the only way, as Stanley Jackie, the Roman Catholic theologian, has argued, the only way that we'll ever know is if these intelligent beings ever visit us. And we sit down and we have a conversation and see just what has happened on their worlds. They may turn out to be Jewish. They may turn out to be Jewish. As long as they don't turn out to be Methodists, that's I speak as a Methodist. John Polkinghorne, if little green men on Mars need saving, then God will take little green flesh. He will do what is necessary. I like that, actually. I don't know really the answer, but the God that I see in Jesus will do what is necessary. As it happens, although Paul Davis says you Christians have problems with this, and rightly highlights something about how we think about sin and salvation, for most Christians, and indeed various other faith groups, this does not seem to be a problem. Ted Peters surveyed 1,300 people, asking whether they thought the discovery of extraterrestrial intelligence would shape their individual belief, the strength of their religion as a whole, or would adversely affect the beliefs of other religions. Across the various religious traditions, the vast majority of believers see no threat to their personal beliefs at all. But, interesting enough, of those who identified themselves as non-religious, they thought that the religious people would have a problem with this. So I think part of the dialogue of science and faith is to simply say, these are interesting questions, but they don't lead to a closing down sale for the Christian church, or indeed pose new questions. They pose those deep old questions of sin and salvation in a new way, and we might not know the full answer, and at times we may say we don't know. Right, final point, Bob, and sorry Keith, and then I'll finish. I just want to say that, in closing, and it seems to me that there is a religious dimension to this interest in SETI. Looking at some of the scientists involved in it, and some of the X-Factor type UFO community, and those who are fascinated by this, a number of themes come out of it. I did this work a few years ago. Themes such as a sense of loneliness in the cosmos, sense of purpose. What is the purpose of intelligent life? Sense of identity. We might only know who we are if we encounter others. Sense of fear, science fiction particularly. The sense of fear of the other in the universe. The sense of salvation. In 1949, Fred Hoyle, in a paper in Monthly Notices, the Royal Astronomical Society, said the motivation for belief in extraterrestrial intelligence was the need of a saviour to come and save ourselves from ourselves, save us from ourselves. And the challenge of religion to challenge to religion of SETI, I think, is that old J.B. Phillips quote, "Your God is too small." SETI allows us to begin to think about some of these themes in a bigger context, and it might bring us back with a sense of humility to stand before a God who is free to create in unusual and interesting ways. I've gone on far too long. I should stop there. Thank you very much.
Thank you, David. Fascinating. I'm sure we have plenty of questions. We've got 15 minutes, I suppose, but let's try and see.
Is this working?
It is. It is for me.
Well, thank you very much for your speech. One of the emerging instruments that the UK is playing involved in is the Square Kilometre Array project, which will be looking at neutral hydrogen at about 1.5 gigawatts. Now, the devices in it will go to higher detection frequencies, and there are carbon monoxide lines and carbon dioxide lines up at around the 3-4 gigahertz region, which is expected that this Square Kilometre Array project should be able to do something about detecting. And with the many, I think there's going to be about 3,000 detected dishes, and they would operate as a sort of phased array, so they could be tracking perhaps 1 million stars simultaneously in a receive mode, not a transmit-receive mode that that's what you were talking about.
Yes.
And I just wonder if you think that might make a sea change to the observational possibilities for at least knowing the rights of the molecules out there within the next 10, 15 years.
Yes. It's a fascinating piece of science in itself, and as someone who's particularly interested in star formation, the carbon monoxide tracks the molecular hydrogen. In that sense, it's an interesting point of view. But I think the point in terms of does it give a sea change to our search for alien signals, that the issue has always been how you survey enough of the stars in the galaxy, and at what frequency do you look? So that if I want to advertise a product, I put it as part of a television program that lots of people are looking at. So if I'm going to look for alien signals, I first of all look at frequencies where I think interesting things will be happening. 21 centimetre line of hydrogen, or carbon monoxide, or a whole number of other lines. And in that way, I hope that alien signals are embedded on that. I think, both as a scientist and as a theologian, I want to be extremely encouraging of such projects. Because I think we have to look at the universe in order to see whether there's anything there. We can't simply speculate about it. However, will it give a signal? It's still a needle in a haystack type of scenario. You then have to crunch all of that data, and the SETI at Home project has been very good in being able to crunch some of that data in the background as you use your own machines. What the interesting thing is, in lots of these experiments, is how little money the the scientific establishment is prepared to put into SETI. It's often had to be funded by private individuals. And is that to do with it's too popular in terms of it's too dodgy science fiction and the rest of it? Or is it actually that it is a needle in the haystack type scientific enterprise? At least with 9 billion, we had a good sense that the Higgs boson was there to be found. That's right. We're still unsure, because of the uncertainties in the Drake equation, whether there is something there to be seen or not. And so I want to say, yes, we need to keep looking, but it may not lead to quick results. Frank Drake thought by this time we would have already seen the signal.
Question here, and rows further back.
Yeah, I just wondered what the barriers are to applying Fermi's paradox to not necessarily the entire universe, but our closest galactic neighbours and things like that as well. I'm just curious as a business.
It's simply the travel time. So that the distances between the galaxies are so much greater than the distances within the galaxies itself. And therefore, you get the colonization time of one civilization coming from Andromeda to ours becomes too great. There is then, I mean, Fermi's paradox itself has been challenged on a number of areas and objected to with a number of ways. One is to say, and Carl Sagan was one of the people who was very skeptical about Fermi paradox. And Sagan provided a number of ways out of it by saying, well, maybe he called it the zoo hypothesis. Maybe civilization does colonize these worlds, but the kind of Star Trek type of thing that you don't interfere with inhabited worlds until they get up to the level of technology that they can become part of the galactic community. Prime directive, the zoo hypothesis, so they just observe us. The trouble with that is that you've got to be a very good zookeeper not to cause mistakes or all the rest of it. It's a very difficult thing to police, not least as we start looking for radio frequencies and the rest of it. The other thing that Sagan and others argued was that, in fact, intelligent life would not want to colonize the galaxy. That we would be fearful as intelligent species of colonizing the galaxy because we wouldn't know what we would discover. And that's where I come back to curiosity and wonder, which seems to be at the heart of the human spirit. There have been times when, famously, when the Arecibo telescope sent out information, Martin Ryle, then Astronomer Royal, objected to it strongly. So Hawking has made a similar point recently that we shouldn't broadcast our position in the galaxy because all of these strange aliens might come and colonize us. I don't find any of that convincing, and Barrow and Tipler in their cosmological anthropic principle book about a number of years ago, I think successfully argue against the Sagan type of hypothesis. So I think that's why I want to just use the Fermi paradox with this galaxy rather than other galaxies.
Colonizing other stars is something that it's a one-way trip. You go and you never come back.
That's right.
I wouldn't want to do that. I mean, with my family, they're probably totally having Faraday Institutes and stuff. So it's not just like colonizing America or Australia. Not to speak of different lands. Even in the nearest stars that years to sustain a local life.
Well, absolutely, which is why I think the more realistic scenario is that we send out von Neumann probes who will recreate themselves very easily. So it's not people, it's space travel. It's simply replicating probes. And in fact, Barrow and Tipler argue that such probes are far more effective than simply sending out radio signals in finding whether there's anything there over the periods of time that you can calculate as a probability. So yeah, although, I mean, this mission to Mars, this one-way trip, which attracted an awful lot, including a particular postgraduate in Durham University who signed up for this one-way trip, is an interesting kind of something about the pioneering human spirit. I agree with you.
So are we going to colonize our own galaxy?
I think we will. I mean, there are some arguments for why colonization is practically important. One is that you spread the risk of a disaster which hits planet Earth. Now, again, Martin Rees has spoken about this. I can't remember the name of his book, but that book which you shouldn't read at bedtime, where he goes through the 7 fatal things that are going to happen, or could happen to the human race.
Our final century.
Our final century, thank you. Yeah, don't read it before going to bed. It's far too depressing in that sense. But if you colonize different worlds or move into space, then the possibility of a virus, the possibility of a comet impact which wipes out most life on one Earth. So from a survival point of view, you begin to say, yes, that's important to do. But the costs, forgive the pun, are astronomical, of course. And the added dimension is that the people who often will colonize are the rich, leaving poor behind. So the sociological questions here are very interesting.
Question on what's the
It's interesting the flying cogs as a new imagery. He talks about all these planets. The Drake equation is never mentioned.
The Drake equation has been very popular up until really quite recently, when because of the different. The Drake equation sometimes gives you a false sense of how easy this is to work out, and it's a little more complicated than that. I'm fascinated by this, by the way. This isn't on my computer, so it's not valuable. Maybe this is a strange message for the gigahertz region of aliens, absolutely. So sorry, it's, but no, I think I rarely use the Drake equation, particularly in popular talks, because it gives you this false sense that actually, if you just put the numbers in, you can get an answer. And it's a little more subtle than that, because the Fermi paradox, for example, doesn't come into the Drake equation.
But if it's secret Prof doesn't mention electrons, he just leaves you with a sense. I mean, his talk finished with the descent into it is insignificant.
The descent, that's a lovely phrase actually, the descent into insignificance. What would it mean? Again, we're holding this sense of the special nature of human beings against the vastness of the cosmos, or the fact that there may be other intelligent life out there. And I think part of the Christian gospel is this sense of you need to learn that you are loved, and that doesn't mean that you then have to negate or put down the rest of creation. So sometimes Christian theology has exalted human beings to the detriment of the rest of God's natural creation. We're there to do as we wish you, this earlier in the day, I'm sure. And there's a way sometimes where, in order to feel that we're secure, we have to put other people down, or other things down. I don't find that in the teaching of Jesus. I don't find that in the Abrahamic traditions. That actually, it's in knowing that you are loved, that there's a generosity towards the other. There's a generosity towards the rest of the created order, which becomes really important. And so you may be small, but you're not insignificant.
I'm going to draw our questions to a close there because we need to do other things. We've got our small groups coming, and I think we'll have a chance to devise other questions for David within those. But can you join me